Thank you, everyone.
Okay, thank you very much for technical assistance. Once again, good afternoon, and now our European participants, good evening, good late evening. My name is Andreas Pinzenöhler, and in case you would like to know why I'm here, I was designated as a technical expert in the year 2011 to an USA project called Rail Topper Model, now known as Rail System Model. And later on, in 2016, the idea came up to have an internationally agreed upon extension of the IFC standard for rail infrastructure. I was going with some other people to participate from the very beginning. And I was part of the technical service team of the IFC rail, done in the context of the new founded IFC railway room up to now. And after we delivered the extension of the specification, today about the ISO standard, and the basis of IFC 40 to a new release of the ISO standard. After we did this, our stakeholders started to work with us. Our stakeholders faced some issues, and this made some of our stakeholders put some additional money in an additional project phase. And this additional project phase is what I'm going to report about. It's a call for participation. Some of you would consider this project plan in some detail. Okay. Now let's start with some context. If you talk about the rail industry, it's indeed quite a huge industry. Asking Google gives some goals between $280 to $290 billion to $270 billion. The difference very possibly is whether it's with the related industry or whether it's the railway business proper. What Google is quite confident to know is the size of the infrastructure rail market, and here we have a quote of some $47 billion in 2021, and some, in my very humble opinion, quite believable expectations for growth up to $61 billion in a couple of short word. Why do we believe this? A couple of months ago, news in Europe came about that the River Rhine, which is large river between Germany and France, fell almost dry. That the River Rhine has a water level of -1 centimeter, or -1. Why? Because the driving lane for the ships was still underwater, but the rest of the... And the consequence of this is, of course, that the transport capacity inside Europe was very much reduced. That's the technical answer we could have. Coming to the minds of the politicians quite soon, is that we can do a lot with extending and getting the rail network. Therefore, I believe the $61 billion immediately.
Figure like the infrastructure building projects or...
Yes, infrastructure projects, new lines, new tracks, new stations, reworked lines. In Europe, we have very major networks, so a lot of the work to enhance transport capacity is improvement of existing lines, of course, maintenance. Figures say that 60% of the life cycle cost of rail infrastructure is during operation. And that's maintenance, that's inspection, that's refurbishment in all our big projects. And there is a very strong trend inside at least the European rail industry to move into the direction of using Doesn't mean that those people really understand what BIM is, but that's the purpose, that's the stated direction they. And it's also quite clear. We have in a rail company a lot of infrastructure projects. Some numbers. One is from one of the companies which is no longer operating, Austrian Railways. They have at least 1,000 infrastructure projects a year. Each project has 2, 3, 4, 5 contractors. Those 2, 3, 4, 5 contractors work together. And now comes the next slide. They have a very specific interest to engage with open BIM. Why is this? Most of those infrastructure projects are funded with public money. This means that out of the reason of non-discrimination, they require an open tender platform, procurement platform, not to restrict the potential vendors to a specific platform. Very important piece to understand in this market. At least in Europe, this documentation, which is flowing between the participants of such an infrastructure project, has to be in an open standard. In some countries, this is already law. In Italy, it's not allowed any longer to make infrastructure projects without an open BIM standard according to whatever is feasible. Right? That's also one of the reasons, and I think Evandro can testify this firsthand, why our Italian friends have been extremely interested and very, very much supporting the work of the last years. That's quite amazing to observe. And the second thing is, the assets tend to have a long life, much longer than the typical release cycle of software. Tunnels, they live for 170 years. Already have this. The old water tunnel. Bridges, they live for 50 years, 100 years, 150. Typical switch in a track network lives, if it's on a very much used track, some 50 years. If it's not on such a very much used thing, they live for 30 years. And they plan for maintenance activities 30 years from now, when going into BIM. So again, that's a major reason that they engage with open BIM. And I already mentioned that in some countries there are legal requirements on this. And in some countries, it's for the time being a strategic decision that they want to change all the processes which are related to infrastructure in the next couple of years, 2004, 2025. Switzerland, I think, 2025 to do this. Yeah. And that's the reason why we had this very well funded in the last. That's also the reason why we have this specific project which was starting. Now, who are the stakeholders? You see them here. And on the right side, you see a special way of representing the work groups and the work packages. Major issue the rail companies are facing right now is to acquire the skills to engage with BIM software and to engage with the contractors and telling them how to use BIM software. And that's the reason why we are looking into requirement analysis. Yeah, we do have the notion of a business case. I'm today reporting of a business case. We do have the notion of a use case, which is a rather compact, rather atomic piece of requirement. And then we will develop for selected use cases, not the complete business, selected use cases, tests and rules for validation. And then we do hope sufficient number of software vendors will implement those use cases and will try to pass the test. And in this interactive circle, we hope to have at the end an reliable checklist for our stakeholders and other railway companies when they try to work with BIM in the infrastructure business process. It's an important part to use the concept. One of the major pressing points in the current situation, they want to use this in contracts for infrastructure design work, infrastructure planning work, infrastructure maintenance as possible. I've seen some contracts where it states if in the course of the project IFC 4.3 is a public standard, then it has to be used in this way. But also interesting to see two of them here, BIM and Mind in France. There are also some industry consortia there. Mind is a French association, and behind that there are some 60 engineering and construction and software services companies which are currently already supporting the infrastructure inside France, I think. Absolutely correct.
Yeah, exactly.
Okay. But it's not only the major stakeholders which is purchasing power, it's not huge power, but it's also the associated industry, which is. Now, what are the project goals? You might have noticed that some of us know each other quite well because we have been collaborating in the last couple of years already on some aspects of this rail extensions, and this should continue. So definitely this is seen as a very positive aspect of the work under the business buildingSMART umbrella, and they are expecting our stakeholders like here. By the way, that also has to do with procurement. Yeah, this is an open platform. Everybody can join, so there is no discrimination. So in the future, they are not having the risk that procurement because somebody says unfair. They had some advantage because they have no other contract. Open, everybody can join. And as I mentioned already before, it's about establishing a methodology which will be used and can be used to develop requirements from the so-called appointing party. That's a term, I don't know. Appointing party, usually the railway infrastructure. And then helps also the appointed parties which have to deliver the digital to develop the requirements to software. And we had some selection process, and inside of the selection process, you know it, Miro doing that. We had now 3 so-called business cases selected out of some, I think it was 9 who have been proposed. Yeah. What can you expect if you indeed join this activity? You will get all the material and the conversation on these priorities, business cases, and the decomposed use cases, polyatomic part, and the test cases which are developed for the exchange requirement. One thing we noted when we analyzed the 9 proposals, the expectations of the stakeholders are much larger than the exchange requirements. We are also talking about software functionality. Yeah. But of course, under the umbrella of buildingSMART, we are absolutely focusing on the data exchange requirements. For the data exchange requirements, in turn, we try to develop the test cases, the test instructions, all those artifacts which are in the future be used as a basis for software validation. And what you also can expect is that you part of some test run of the buildingSMART validation service. Project plan. Of course, we do have access to our stakeholder experts, so you also get, if necessary, the necessary contact and time with the various stakeholders, and of course to collect input and to them. And of course, it's also visibility, which you obtain your company's consent, because developed this software vendor participation platform, always also with making sure that the participants and the efforts are made visible to the financing. And the checklist we want to develop, how far we come, how complete and will really be. I expect this that for most infrastructure projects in what they found in Europe. Now, what are those three business cases? The first one is called IC Model Federation. Second one is stationing and alignment. I understand that we had some interest in the report. And the third one is a very high priority case from one of our stakeholders, which are also catering for railway infrastructure. What is this in detail? Now, first, we do have a website. I can't right now. That's why I put it into the
I'll share.
Yeah. Okay. So the website and the material we are presenting right now can also be found in the presentation on the website. Also will get the slides. And here are the business cases which are documented on the website. IC Model Federation is here. I'm now going to the image here. Is a short overview about railway system of systems. Railway is a highly engineered system of systems thing, and those are the subdomains which have been used to structure the project work. The track, energy, signaling, telecom was in the core of our project so far, and now we definitely need to reach out to the other parts of IFC and to test it with bridges, to test it with tunnels, to test it with typical vertical beam artifacts. Model setup, georeferencing, spatial structure, whatever that is, alignment, linear positioning, and any kind of vertical beam models plus roads, they are in the scope of this. Don't be afraid, it won't be everything. Yeah? What will happen is that we will try to find a representative data set, maybe two data sets from our stakeholders, where we can provide test instructions and test cases for the principles of the problem. And quite sure that we're going to discuss this in detail, referencing, for instance, in combination with more than one vertical beam model to separate engineering coordinate systems. business case is this stationing on alignment. Alignment has not only one meaning, at least three meanings. The very typical rail issue is track velocity with the kinematic parameters to make sure that the trains can move with a certain speed. Not in the typical scope of software vendors, but the other two things are. You want to have some line of reference to organize your model. That's very typical an alignment issue. And then this also is a reference for stationing, for linear referencing system, which is the absolute natural referencing system for linear infrastructure. And this role, they are documenting since a long time. Computers have been introduced. They are documenting all the assets according to some linear referencing scale along an alignment. And interfacing with this existing system, this legacy system, is now a challenge which is faced since the rail companies engaged with BIM, so this GIS, and there are some functionality has been developed to map this linear referencing system position to coordinates which can be used vice versa, going back. And the same kind of functionality, of course, will be required if they use BIM. And this should be clear now. This business case applies to all rail domains, and the third one is the focus on the cabling and cabling laying infrastructure. Stakeholders say they won't address high voltage electricity transport, but cables connect all the relevant assets. Telecommunication is a part of a regulated system of systems. Signaling, making sure that the train transport is safe. Addressing the track infrastructure of switch engines, and you know where you have to know where the switches are, and then you have an engine which is putting the switch left side, and to them we have power cables, voltage power cables, and we have communication cables. So this is a very basic piece of design work. Not quite sure whether this has focus in the rail design or our area, but for rail.
Andreas, what was the reason for leaving the high voltage out?
I don't really know. They're afraid of electricity. Maybe one answer is that I'm not quite sure for how intense this is actually. At some time, the idea that high voltage transmission networks have to be separated from a rail company. So many of them are buying the power for the trains from the public provider. It's not their competence. Maybe that's the reason.
My understanding was, most of the funders of this, stakeholders on these scenarios, use overhead electrification.
Right.
So that simplifies it. And secondly, simpler solution than the telecoms. Fixed telecoms, two gaming systems are totally separate anyway. Fixed telecoms, because the high voltage is simpler, you've got the solution that could be used for voltage.
I think the base is the power substation, and this is in scope, but from the power substation down to the power station proper equipment to be on. Yeah, and this is also some layer issue. Yeah, we do have cable ducts, and inside the ducts we have cables. And that's what's interesting to our stakeholders, what cables are in there, and where are they connected. Okay, I'm absolutely happy to discuss this much longer with you, but this is already my last slide.
Thank you.
Indeed, if you imagine that this project is interest for you, maybe more detailed information around on it, please contact Evandro. He's taking charge of our software vendor communication, and yeah, it would be just great if one or the other of the audience here is start at the beginning. As I said, many of the aspects are also true. Thank you very much.
Thank you.
No, stay there. Stay there. I'm sure there are questions for you. So clear?
I'm fine. That's a good reason.
Hey, the next session is about reviewing a little bit the use of the form, but why don't we link with the presentation from Andreas? So let's start, if you have any specific interest on topics that Andreas presented. I don't want to talk for the next hour, so that's why I'm asking you to.
I found it very interesting. I've been involved for the last 2 years on this validation. I'm not surprised the vote in the way they did. This particular building here has a large number of Revit building developers inside. So we've got the best people here, and most of the best people come from the building side. And also, I would think the ratios of software engineers or civil engineers working in rail is about 1/10 of the number of civil engineers working in road and railways. So it immediately comes down. But my representation in charge of rail development is rail engineers are millimetre perfect. Road engineers, doesn't really matter if you're a couple of inches out, a few feet out, no one's going to die. Rail really is concerned on this and having accurate, well-designed and well-documented rail models. Again, on maintenance, about your 15, 50, 75-year plan, once a track's built, generally it can be shut down for 6 hours overnight or 8 hours overnight, and perhaps an occasional holiday weekend. Don't close the rail network down, so you have to plan ahead. This is why the BIM models are incredibly detailed.
There's a big European rail companies, I'm not sure about the situation here in the United States, totally determined to make this work, not to have it fast.
From the U.S. side, our stakeholders aren't quite there yet, but they're coming along. So Ian's been working that along with some of my colleagues at HDR. Most of our effort has been put on bridges. The next big effort is going to be on roads and other infrastructure. But the organization really responsible, because our rail system here is mostly privatized. There's very little that's actually owned by federal government, and they're kind of behind the times in terms of asset management and project delivery, and we're just starting that education process with them. I think it's great that essentially European partners got far ahead and took care of this problem. Then it would be a whole lot easier for us to adopt and move forward. I think we can reciprocate by the work that we're currently doing with BIM for bridges and structures, that there's something that we can bring towards the effort for rail when it comes to bridges, and then also, and Evandro and I are going to talk about this too, of what our project is trying to do is also set up unit tests to deal with all these issues. But I think being you guys have already started at some of these higher level ones like georeferencing and alignment and all that, it kind of takes some pressure off of us because we don't want the vendors like doing a whole bunch of duplicate testing. We'd rather just have like a nice interlock and say, oh yeah, we've got this covered, and you know, we know it'll work. If it works in this domain, we know it'll work in all the domains. So I'm looking forward to that from our point of view.
Tests and this also has much to do with culture.
Yeah.
Rail culture is very much determined by the safety of the running train.
Yeah.
The developments which have a direct effect on the safety. Usually some minimum twice the budget, sometimes 10 times the budget of an of the project, mostly going into requirements definition, and that's really in the DNA of the rail engine.
So curiously, why is the rolling stock is out of scope for the slide like number 4 or something? Because rolling stock is pretty.
Rolling stock, that is a talk about rolling stock.
No, it is
Slide 9.
Yeah, that graphic.
Oh yeah. Okay, because it gives you a complete overview. And the direct connection of rolling stock with BIM modeling is about the track gauge control. Yeah, you have to make sure during planning, design, and commissioning of the track that a specific class of rolling stock can pass through without hitting the bridge, without hitting the track. And that's the aspect of rolling stock which is important for BIM. Otherwise, it has to do with maximum actual load, minimum radius, this kind of aspects directly affect track geometry, and track geometry is a very important perspective on alignment of the rail. So it has connections to BIM, but not in this direct way as you can expect it for a bridge. Bridges of affecting the design work. And collision detection will come up. As a matter of fact, collision detection was one of the 9 proposed use cases. As another one was visibility of signals, but this didn't get this priority. So this might come up later.
Yeah. Originally, I think since the very beginning of the railway project 5 years ago, rolling stock was out of scope, so they never specifically touched the topic. Of course, making sure that the parameters to do whatever calculations like the train gauge are there. So all the alignments parameter, the contact line, and everything around that can have a clash with that. They wanted to make sure that these things are modeled. When it comes to the train gauge itself, there's also one class in IFC that you can use to model the rolling stock as a mesh. But that use case was not prioritized because it's mainly a software feature. Like, given these parameters, I have a software that can make a simulation and create the maximum gauge and then export it as a mesh to make sure that I have a clash. Very much a software feature rather than making sure that IFC has enough semantics to do the dynamics of this calculation. So it was probably too much advanced for the time being, not really impacting in terms of value.
And again, on the gauge, most of the owner-operators in Europe have well-defined, well-trusted ways of calculating gauging or have a gauging team. The results of the gauging can come out BRF or Polymesh, but they want to use their software.
You see there is one tunnel connecting Austria and Slovenia. When it was built in the early 1900s, 1905 or so, the plan was to have 2 parallel tracks. The tunnel was finalized and they made the first 10 test runs. Said that they found out that two passing trains would collide because in the circle in the curve it was highway enough. This tunnel now is a one track.
Yeah.
But it's long ago, so usually the procedures are in place to make sure that this works.
I think part of this too is, we had this with the bridge project, and Connor knows this, is we identified a lot of use cases, but having to prioritize, like, well, what's the low-hanging fruit, right? What can we immediately make use of? And then once you have that one done and people are, moving forward and running it, then getting these other use cases satisfied then becomes a little bit easier. You got to start somewhere.
Yeah.
I think it's one of the things that's necessary in the state to get folks going is evangelization and bringing the type of information where the rail people are, like TRB, because we do have some rail entities that are starting to do some really interesting things. LAX and their automated people mover. Our system up in Southern California, just for projects that have some of the strict requirements I've ever seen. The thing is that they don't, as entities, they're putting out their own individual requirements. They're not thinking about, what it looks like as a whole and how IFC and being part of a bigger open standard. So where roads and bridges had the benefit of, meetings at AASHTO and all think together as a group, there's no one really pulling together the rail entities right now.
Any conversation thanks to Amtrak and FAA. The conclusion was that they're really interested. So probably what you're talking is the bottom-up approach. We went top-down. They're very much interested, but they say the ownership of the railway line is very fragmented in this country. Some of the people in the value chain, they say, according to them, they don't believe in technologies such as email. So they still rely on facts. So that's part of the vision, let's say. But
knowing that our rail systems are behind technology by comparison to the rest of the world.
Yeah.
I would point out, though, that just the funders, plus the other European nations who have already said it, that they are going to adopt IFC, and India, it probably accounts for close to half the world's railway track will be covered by IFC mandates in the very near future.
As mentioned, we have the Chinese colleagues on board. They build yearly the entire length of the Italian network every year. So,
what's the relationship between IFT, which is the exchange specification, documentation, and authoring tools? But what is driving and what is following? Do they have tools for designing rail and their documentation and what's needed exchange specification, or the idea is that data exchange specification should provide requirements for modeling?
probably we should answer to what has been done in the last 4 years with rail. So they had a lot of requirements.
What was the actual situation on the ground? I don't know. You for doing all rail projects, but the requirements of case and all.
No. I think Andreas summarized it well. So they had requirements on the business level. I would say that the level of maturity of these people using tools is, let's say, very diverse, from very green to very mature. So they also had some software requirements. It's really advanced, but sometimes they don't have experience at all with any tool. because they're very much focused on maintenance and these operational and use requirements. So it's a very diverse mix of requirements. But we had 10 stakeholders in the last project that agreed on some requirements that made their way into the IFC for the tree specification. So you can see that the IFC for the tree specification quite a big amount of requirements. But yeah, I cannot say which one is driving.
Yeah, I would say a similar case with the BIM for Bridges and Structures project here in the States is that while our focus is on, well, so the one exchange we're focusing on right now is design to construction handoff. So what the bridge designers end up with their model, it goes to the contractor for quantities and costing, construction, scheduling management, staging, and detailing fabrication of elements. And we know that while there's software out there that is able to build these models, and we've seen a lot in the last 4 years of actual bridge modeling packages being developed, we know there are going to be some requirements that come up just from the modeling side, even before you get to the IFC exchange, is making sure that certain types of models or certain types of elements have to be accommodated in the software, right? Because if they can't even model it, then they're not going to be able to even exchange it.
Yeah, and it sounds like kind of application will drive.
Yeah, it helps do. Yeah, it helps do that because it says, well, ultimately in the end, I need the data, but if I can't create it in the first place, then I got to fix that part first.
I think that's part of the beauty of this phase of RAID. I think they have a nice, probably it's now too early to show it, but they have a nice methodology that they want to test through this process and possibly replicate it in the future. And this methodology at a certain point has a moment when you derive requirements that are going to be sure about the content of the file. And these are linked to the software features that in their mind is the software feature can be developed to fulfill that requirement. So as Andreas said, they're not going to dig deep into the software feature, but I think it's a great piece of knowledge for you guys to know which software feature they envision to use to produce that data in that structure.
So in a sense, IFC will take place of documentation. Because in the old days, you would take drawings of a bridge, for example, and say, okay, that's what contractors require to actually build the bridge. So our authoring software should at least be able to produce stations.
The way that's quite a good perception, yeah.
Right? And what doesn't go to the drawings,
okay, that's a very good perception. I think the open data, the open BIM perspective is precisely about being open, long-term, available digital documentation. That's absolutely an issue. But besides this, all the process aspects are very important. No? Just imagine 1,000 infrastructure projects a year. If you only save 1 hour for each project, it's 1,000 hours. If 10 hours, it's 10 hours. That's very soon, very substantial money. Yeah? Have a lot of motivation to go into open data documentation, and here BIM with buildingSMART fits the bill almost perfectly. If we can prove, and that's also some aspect of this project here, that this hopes, I would call it hopes, not really requirements, because you can't test, just show that there's a good chance to fulfill this. And I think that's also the reason why we do have this large group of requirements which has nothing to do with data exchange, but with software functionality. And some people in the field have, I would say, a very good vision what in the future, when indeed 3D modeling is used in our case rail and infrastructure in general, what new business processes, optimized business processes, new methodology can be used. I talked to some of you about alignment. The current way over the complete world, I would say the complete world, is done alignment now is it was done some 120 years ago. Okay. So we have this 2.5D approach. We're doing a horizontal plane layout. We're doing a vertical plane layout. To say it's 2.5D, which it is. But in reality, it's not a circle. In reality, if you do have a gradient, it's a helix. Nobody is calculating the helix. They're all calculating the circle and the transition bands in the horizontal. And there are now some ongoing research activities which maintain that this is very bad, because if you do it in proper 3D space, then you get much better solutions for the kinematic properties. Nigel said that the way people want to have millimeter precision, they want to have millimeter precision everywhere where the kinematic is. So maybe in 10 years' time, 15 years' time, one of you comes up with a 3D alignment model optimized for the kinematic things. It won't happen while I am active, but now we have the basis, the foundations for the tools the people would require to do this. Once the mass is established, it will take some other 10 years for the regulations to be adapted. But yes, it will happen sometime.
And I think another way to answer your question too is that while we're focusing on using IFC as a means of exchanging information so that lots of different tools can be used somewhere in the process, we also know, at least from the U.S. perspective, it's going to take a while to make that transition. So right now there's a lot of tools being used, and they're producing as a project deliverable essentially PDFs, electronic 2D drawings, right? Now, there's been a lot of piloting over the last 10 years in the U.S. with actually doing project delivery using models in infrastructure, much like buildings, because a lot of it is firms, especially like engineering firms, who already have experience in the building side. Now they're just applying that to like bridges and roads in the U.S. The thing that is interesting for AASHTO and the DOT stakeholders is that, well, then it also opens up the ability to say, well, when we get a project deliverable, what if we went to a model-based project deliverable, but we want anybody to be able to provide a model to deliver? And then we don't have to say, well, yeah, we know you guys are providing it via Revit or via InfoWorks, but we also need it via DGN or, Bentley and all that. And instead, you say, no, we'll do a model-based delivery, and using IFC, then anybody can pick the tools that they want or need, but then it also becomes a basis for data that can be used further down the road, right? So if the department, the transportation department is confident and experienced enough, they will actually leverage directly that project delivery model down the road into their asset management systems.
It's also a big responsibility for IFC, because anyone needs market there.
At one point or the other. It doesn't have to always, the other way to look to it is additive, right? So it's not that everything has to be in the first IFC model. It's saying we know that there is a means and a repository to keep adding information in there as it builds. And then for the asset owner, it's saying, okay, well, I know I'm going to get the information via this way. What I choose to do with it and what tools I use to make that are up to me.
I follow on to that. I look at buildings from around the world. I look at buildings from around the world. Revit, about 5-10 years ago, started to appear with really rich metadata on it. They put metadata in what this is going to be painted with. They just build it in the model. It's second nature to a Revit engineer. As they work on the model, they start expanding the level of detail. Civil engineers, US, I'll probably get LOD 100, almost no metadata on any object. aimed to print out. Go to construction and someone else works out and start that debate. On Europe, I'm probably at level of detail 350. There's quite a lot of the drawings coming with rich metadata. And one of the rail group here, they're going to insist level of detail 500. They want to know the sleeper, its serial number, what bolts are used to bolt it to the track. That data is going to be in there. It's going to be forced. It's going to be requested. Whether or not it's on the early stage or very early or detailed design stage, you're going to start seeing metadata-rich models. Metadata is more valuable than the actual draftsman's time. There are so many workflows downstream you can do with that data.
Consider that 8 out of 10 of the railway founders, the railway stakeholders are infrastructure managers and operators. So these guys really need these kinds of information. Take the truck for years, they really care about it. Actually, we were surprised the first year when we started collecting requirements. Usually when you go to facility managers in building sector, they are not really sure what to ask for to the designers. These guys have full databases of information that they use. That was not an issue. Actually, we need to cherry pick. Okay, let me try. I don't want to keep up all here to the very last minute, so let me try to do a double backflip. I'm trying to link the current presentation by Andreas and a couple of major comments and feedback that we got in the forum session. First of all, we got a lot of good feedback in the forum, and I need to digest all of them, so give me some time, but they're very good materials. Some of the questions spotted that the communication-wise we need to improve, because I saw many questions that the answers of which already exist, but simply are known only to the ones that are part of the previous effort. So the newcomers have questions, we already have the answers, but now they are scattered around. So part of the forum activity will be to gather all these resources and put them in a central place so that every newcomer can see them. So first of all, that's the first thing that I noticed. Then I prioritized 2 or 3 things out of your and those are the ones that I would like to link with the current presentation. So sample files are probably the biggest hit, followed by tests and examples. Agreement and consensus is probably the third one, so a lot of requests for agreement and consensus. And I'd like to try to use the rail example to cover this. So, and that's probably where the double backflip comes in. So, in rail, they are producing these requirements for contracts, so using plain language. And we have people in rail that are going to translate those requirements in many languages. Okay? And these are IFC agnostic requirements. And as we said, they are both on content of file and features. So one typical example that we used was that every alignment has to have a horizontal layout, vertical layout, and cant layout. Okay, so let's say this is a plain language version of the requirement. Every alignment should have horizontal, vertical, and cant. That's the plain language version. So this is probably going into contracts translated in many languages. The other layer is the IFC version of it, because we cannot test this. Okay, so the IFC version of it, there I go by heart, instead, let's say the formal, something that we can build formal rules out of it, is every IFC alignment shall net exactly one horizontal IFC alignment horizontal, at most one IFC alignment vertical, at most one IFC alignment counts. Okay? Where exactly, at most, and at most makes a lot of difference. Okay? So this is expressed in IFC language. This can be put in a formal rule, coded, referenced by tests, and test automatically. Another example. Align? Yep.
IFC law, could that be expressed in IDS?
To some extent. That's a good question. To some extent.
Okay, so I think it would be good to think what cannot be expressed in ideas about that. Like RES is language for requirements.
Yeah, in the RAID project definition, they say the formal rules. They didn't mention explicitly any technologies because part of the work would be, let's check what the existing technologies allows us to express in a formal way. If not, we will find another way to do it in an interpretable way. By the way, it's linked with the validation service discussion, okay? Another example, every alignment, horizontal layout should use in Italy straight line, circular arc, and closely. Okay. It can also be translated into an IFC. So every IFC alignment horizontal should match segment called alignment horizontal segment of type linear circular arc closely. So again, something like this can have a nice computer interpretable counterpart. Okay. Then let me do my double backflip schema. Okay, so if you take this and you add, let's say, the software functionality, software features that the user and say, okay, I need these software features to do this, okay, to model alignment horizontal, to model alignment count, to use these curves, okay. Again, we say this is out of scope. But if you take this, add the data set that the regular people are producing, they're going to put together. Basically, you have a test. So what they're defining as unit test. So here is the link with the forum. So in the forum railway, but in the future tunnel and bridge from the US, will contribute with something that can be checked automatically, that is based on a data set, maybe as some reference to a preferred software feature, okay? There's a strong link with a plain language requirement that can be used in contract, okay? Optionally, they can refer to some buildingSMART formal rule, if it's public, if it's there, why not? And the idea is that in this way, we're also testing the scope of MVD. So we already mentioned the idea of involving vendors in the definition of the MVD. In this case, we're going to be saying, okay, the MVD, the alignment-based reference view, something that includes for horizontal segments only these two and hammered and some other curves, and doesn't include DNS bed, for example. Sorry. This is also another way to scope and test the MVD scope, you know? So, in essence, this is trying to say that what Rail will do is very much integrated with the validation service because they're going to produce formal rules, and it's also integrated with the forum. So the effort of the forum of producing tests and the IC file that comes out of these tests, once validated, is a very good reference file. So that is about closing the circles of I need a stronger test with stronger rules to formally check that we have consensus on things, that the structure of the file is correct. I want to have an IFC file example that I can refer to. So, pretty ambitious initiative, but I think we're trying to put together the parts that are needed both by stakeholders, because we need to express the requirements, and be sure that the IFC file that comes out of it is good. And on the vendor side, you want to be able to be sure that the IFC file is providing is actually what the stakeholders really want, and you want to be sure that your customers are able to deliver this for the moon. So that was the double backflip, trying to exploit a little bit what we're going to do in the forum, thanks to this project. And
yeah, back to what Pasi said. Like each time you are saying shall, should, we are kind of talking ideas. Just to make also a link to our discussion tomorrow, I think ideas may be taken into account in this.
Yeah.
I mean, if you create requirements, you say shall should, you want to check an IC file to see if it's matching. That's kind of the idea.
Yeah.
So,
Just kind of thinking that I think we have like excluding geometry from the scope of ideas.
Geometry for sure, probably.
okay.
But, what I'm confused. What I'm saying is that you haven't mentioned a specific technology because having stationing done properly according to the concept template that we have at the moment in IFC for 3 means that going by heart, but you have to have an IC reference that is linked to a local placement, that is linked to a linear placement, that is linked to some properties that define and capture the mileage. So it's a fairly complicated concept template that you need to fulfill. So these semantics is a very rich one. So if you want to automate some tests on these, probably all these relationships cannot be afforded in IDS. But again, they've been fairly open and saying we're going to use what exists, not we're going to use something that is computer interpretable and that is suggested by buildingSMART. So buildingSMART already is using some technologies based on working to create some rules and some checks, so probably we're going to leverage on the same technology. But again, everything has to be better understood.
I'm hoping you've simplified that check, because in an RC file that's multidiscipline with rail, bridges, roads, pipe networks, or a whole load of other uses, alignments are used for an awful lot of use cases. That check should only be on the rail alignments in the file. Because the other curve types exist on any other.
Exactly, alignment is a essentially vague concept used to describe everything that is a linear nature. Yes, probably one of the challenges would be every INC alignment of this type, or with this classification, or with this name, or with this. Let's find the key. Should follow this rule. Yeah.
For the question, how far you want to go in validation of the IC model based on this formal. But whatever rules you define this way, it's possible to create a model that will satisfy all the rules, but will still be completely wrong, for example, because some rails, these two rails with the tunnel are too close to each other. So
the short answer would be, I think that
this can be, and probably there can be additional analysis software that will run a lot more complex rules, like and simulate and electricity consumption and all this stuff. And it will do it through custom code.
Yeah.
So how much you want to do in formal definitions, how much just the...
I'm going to give you the buildingSMART answer, and then I'm going to do the railway one. So the buildingSMART 1A, we're going to prioritize, or we're going to let's say support rail and then prioritize the rules that have an impact on the, let's say, international consensus. So having georeferencing done properly is something that we want to be able to check on a consistent level to all the vendors. So there are some rules, some checks that are of higher priority to ensure interoperability. So these are the ones that we will, let's say, sponsor more in terms of. I think that rail will have their own preference, and probably they will have to understand how many rules are involved in one test. Because at the end of the day, all the rules need to be formalized in a test. And if the test has too many rules, probably it's not as appealing to
That's
vendors.
exactly my question. You don't have to formalize all rules.
No.
Later, you can just encode these rules.
The most
Is your test, right? Which will make them not readable and
the short answer is the most impacting ones, where impacting varies a lot depending if it's buildingSMART or railway.
Okay, I would like to make maybe 2.5 comments. First one is to Nigel. I'm in charge of the test case elaboration of the project. And what we really would like to do and what we will try to achieve is to have a very homogeneous small test cases. So that one thing, one requirement is tested, another second, another third, another fourth, another. So having one test for one requirement is a major restriction for my work. Then I'm not quite sure what you have been addressing before, but I also would like to state that our stakeholders would like to have some technology at the end will allow them to not only define their requirements for the information they have to expect from the contractors, but of course they also would like to have some technology in place that they can check whether the contract delivered what in their contract was. Now comes the tricky part. I'm not quite sure that we can really start to address this in our project. This will be very specific to specific country regulations, to specific company regulations. I think it might be the case that we have one or two attempts to look into this localized model checking. But the requirement is here, so we need it. Then the second and a half statement, I'm not quite sure that Peter Bond on the call. Peter and I, we worked on implementation of the formulas for the transition plan, and what we ended up with was producing point lists. We compared values in the point list with implementation and for my implementation. Point list example could be extended, especially looking into the issue of stationing. The technical issue to extend this point list example, station values. At the time, it was meant to support interested software values. Some reference when they're doing the implementation. Whoever makes it into some formal software certification or testing, I don't know. Definitely in scope of our work. Look into this.
Just very quickly, I'm already seeing in contracts where owner-operators or consultants who are hiring other people are saying, we'll deliver an IFC and it will pass the IFC automation tests when we're building smart, but our own. And if you talk to the owner-operators, they're saying, well, day one, it might just be something simple. What's in the alignment? In 5 years' time, a very complex series of tests, automated tests, that when you deliver the file, they just want to pass. That guarantees, to some extent, that the file will be usable downstream. Not guarantees that you haven't placed a tree in the middle of the railway track or a building upside down. That's totally outside the scope. This is automation tests to prove practical requirements or even some geometric requirements. That's it.
Many railway operators are really focusing on that because their focus is to make sure that the data can allow them to fit in the downstream processes and tools. So they're very much on semantics, making sure that the data are there, structured in the way that they expect it. Actually, some of these tests, with the formal definition of rules and the way of checking things, Italians, they already had some. So they are using this project to find international consensus on some of them, of course, not everything, but they are already working in this direction. They are challenging their software that they are buying to apply to some of these, because otherwise they will not fit into their downstream processes. Questions?
Hopefully very quick.
Yes or no sort of question. The three business cases aim to be fulfilled by one MBD or by three MBDs?
I'm not in the MBD business.
No, the idea is that all the three railway use cases will insist on the alignment-based reference view. Actually, the work that the vendors are called to do is the current definition of MBD, which is not final, okay, is well scoped. So if we say a couple of these transition curves are too restricted because they are specific to certain countries, we will need to take them out of the MVD. But the base MVD, it's always the same one, the alignment-based reference.
Since you've done 3 separate
No,
tailors, this one.
Okay, this one. The challenge, probably the most challenging one, which is not really impacting the MVD, will be the IFC model federation, because it's half IFC, half software features. So it'll be challenging. So it's slightly different than the stationing use case.
That model federation, what I can, okay, let me guess what it is. So if you have a rail model,
Yeah.
and then you have a building model of a station building, and that is building model is located with the alignment, so they should then get in the right place.
The part of the project is to understand what they mean. Implication of federated files or federated models, let's say. Probably we are not even talking about files, not sure. But just to give you an idea of how big the Pandora's box is, and we're not going to open it now, is think about 2 models coming together and you want to know the mileage of the signaling along the alignment of a 60-kilometer railway line like the one from Edify. The alignment starts in another file.
So it kind of sticks out of it.
Yeah, so there can be many workarounds, like you replicate the alignment or you make sure that you replicate some reference point. I don't know. I really don't know. That's the scope of the business case to understand this. But usually measuring and querying data that have implications, let's say, or a relationship with other files, probably one of the main challenges of federating models. But this is very linked to the presentation of Greg about cherry picking from different sources. You need to be able to do that. Even if we establish a mechanism to measure something that is in the 3rd file and the origin of the alignment is in the 1st file, I need to be able to go across all of these. It's very much a software feature challenge. And then there is the IFC implication, but making sure that these data are there, that everyone can query it. Not an easy topic, but I know that some vendors like OEA prioritize IFC model federation in their roadmap because the industry is asking for that, especially for these large infrastructure files.
You're doing rail electrification. Color to this. If you're doing overhead electrification, typically each individual pantograph cable is 1.5 kilometers long. Typically, you might do 5 kilometers in one model, and then you'll do that next 5 kilometers. If you're looking at a line, saying going from London to Scotland, you might have 100 of these working in multiple coordinate systems, and the digital twin, federated digital twins, they need to be millimeter level when they join up. That is not good. Signaling team working on separate models, so they don't care about the overhead electrification. Their models need to also fit perfectly. Extremely difficult to get right.
Concerning signaling, there is a mega trend which should be taken into consideration. In former time, the signaling unit is about interlocking very locally, mostly one station. Nowadays, one dispatcher is in charge of some 15, some 20, some 30 stations. And if indeed, at some point in time, in the downstream of the expected working beam model, it would indicate that the working beam model has this certain stations inside. Trying to give you some perspective of what it's found at all.
So just to say, railway is a very fascinating topic. Why don't approach Andreas, Nigel, or me over dinner? Leo, one last word? For me? Yeah? We're closing the date. Yeah, thank you.
Thank you, but that's not...
Yeah. 2, sorry.